Okay, so today and tomorrow we are going to this whole chapter is going to be about right triangles. Specifically, right triangles. The whole chapter. We technically haven't started the chapter until today. So what we've been relearning the past couple days is going to be in the sections that we do this week, like working with radicals. Okay? Yeah.
I feel like it was easier last year.
Okay.
Yes, we did. Yeah, we did. Yes, we did.
I learned from the system.
Well, you still learned it.
So you learned it last year with some variables underneath also. Okay. We did in 2 days what you would have done over like a week last year. Okay. Because it was review. And if you don't feel comfortable with it, then you need to come in for extra help. Jonah.
Does anyone else remember doing this last year?
I did. We did not do this last year.
Okay. Doesn't matter. What did I just ask of you? Yeah. Okay, Jonah. No more questions through the whole class, please. Do you listen?
Kinda. Wait, what'd you just say?
Okay, I want you to draw this triangle. Draw this triangle. Page 244, Aiden. Up there. Up there. Up there.
Jonah, there's pencils on what page? I was looking for an ice cream.
What do we call this side over here? And the other two are called legs. Then it should be an easy section. That is my marker that I use for those boards. Put it back. Get out your student journal. Okay. Now, you know that the Pythagorean theorem is a squared plus b squared equals c squared, where your legs are a and b and your hypotenuse is c. Okay, we know the Pythagorean theorem. I'm not taking that away from you. But what I am going to do is I am not going to let you approximate with decimals anymore. Did you hear that, Jake? No more decimals. Get your student journal out.
Oh, I don't have one.
No, get out a notebook to write it down then.
Jake, you want to borrow mine?
You do not want to borrow it, Jake.
Get something out and write this down. No, no,
What if I use my own marker?
no. Okay, so what we are going to do, we are going to use what we have just been talking about in our radical review to give answers. Okay, so this is not drawn to scale, but here's a triangle. It's a triangle. X, 7, and 14. Okay. Red, which one is the hypotenuse? The hypotenuse. So x squared plus 7 squared equals 14 squared.
Huh?
Thin ice right now.
It's thin as what?
It's hard to
You
focus with
are on thin ice
those.
right now.
What? Okay, yeah, I understand.
It's hard to focus with them next to me.
Sometimes like I would do it where I did like a square root and then I did like that, like you have to square it at the end, right?
Yeah, we'll get there. Okay, so 7 squared is 49. 14 squared is 196. When I subtract over 49, what is 196 minus 49? 147? Okay, so this is where we square root both sides. Now, instead of putting this into our calculator for a decimal, I don't care. But thank you. It's 12. Oh, it's a little bit more than 12. I agree. A lot of it less. Okay.
12.5.
Okay, guess what?
12.124 something. It's 12.5. 12.124. We're not doing decimals anyway. I'm just saying close.
Nobody's wrong right now, and nobody's right.
Okay.
Okay, 147. Not prime. Dalton? The what? 49 times 3 is what Dalton says. So x is 7 radical 3.
What's like the reason for this? Like why don't we just do decimals?
So can you trust me that working with radicals will help us when we get to other parts of this chapter? Okay? Oh. I understand that you've done the Pythagorean theorem, and I understand that some of you don't really love working with radicals, but it's going to help us as we move forward through the different things in this chapter. Those of you who are going on to, oh, that's everybody, Algebra 2, everybody's going to go to pre-calculus, and everybody's going to go, maybe everybody's going to go to calculus.
At some point.
Stop being jerks to each other. Can we do that? The person who asked me the question no longer even paid attention to me because we're so worried about other people. You all are on the track to take calculus. And if you're going to take calculus, you need to be able to work with radicals and right triangles. Please trust me on that. This is the most important chapter in geometry that will prepare you for your future in mathematics. Cohen.
Take calculus. You don't have to take any math or
There are 2 levels of calculus. So your senior year, you can either take Calc 2 or you can take statistics.
what is statistics?
How do you have?
I think you only have to take
Um,
3 years.
So statistics is like, I mean, mean, median, mode, range is like the most simple statistic stuff that you can do, but you do all of this like data analysis. Okay. So to graduate, technically you only need 3 years of math, but if you are on the college track, you will take 4 years of math. You will take 4 years of math. And if you're not going to take 4 years of math, you should not be in this class. You are going to take 4 years of math in high school.
It's required.
Go to college.
Well, yeah, what if we don't?
What if you don't want to go to college?
Oh, Ben,
Yeah, you told you were.
Doesn't matter. Right now, we're going to do this
I'm
example,
literally 13.
which is why we need to stop worrying about being freaked out for 4 math classes in high school. That is the norm, taking 4 math classes in high school. You're going to do it, and it's going to be fine. Write this one down. So since x is across from the right angle, it's our hypotenuse. What's 4 squared plus 6 squared?
That is.
So we're gonna take the square root of 52. Now, 52 is 4,
13 and 4.
4 times 13. So x is 2 radical 13.
I have a question.
I cannot hear Colin.
When we were doing square root earlier, theorem, if we put a radical, would you accept that rather than a decimal too?
Okay, so from in this chapter, I want reduced radicals for your answers. Okay,
He was asking about the chapter. Yeah. If you would accept it.
right. So now I'm saying in this chapter, it has to be a radical that's reduced.
He's asking about last chapter, if you would have, if you
The past
if
is
you
in
would
the
have
past.
passed.
Okay,
I was just wondering, like, if I knew how to. No.
I guess I'm just confused about what you're asking.
If you would have accepted it on the test last year.
Right.
Not last year,
Bryce is
last
just making it
chapter.
more confusing.
Would you accept? Because they're doing the best.
I'm pretty sure I did. Yeah. Yeah.
Wait, people.
You did it.
I don't know, but I'm pretty sure I did. Okay. Can we please focus? Have you heard of the term, just a simple yes or no with your head? No, no noise. Have you heard of a Pythagorean triple?
No.
Well, okay, let's try that again. With an either shake of your head. Have you heard of a Pythagorean triple? Okay, so Pythagorean triple are 3 numbers that when we put them into the Pythagorean theorem, it works and we have a right triangle. So 3, 4, 5, 5, 12, 13. Those are Pythagorean triples because when we take 3 squared plus 4 squared equals 5 squared, we get 25 equals 25. Okay, 6, 8, 10, 9, 12, 15. Those are all just multiples of 3, 4, 5. So they're kind of in that same family of Pythagorean triples. Jonah.
Is this like the thing we did last, like last sometime? It was like where, like the first 2 have to be bigger than something.
Okay, so that's just to make a triangle where the first 2 needed to add up to be bigger. Okay. To make a 90 degree, to make a right triangle, it has to satisfy the Pythagorean theorem. Okay, now what if we put it in the Pythagorean theorem and it doesn't work? We can actually decide whether we have an acute or a right or an obtuse triangle. So if you look over at the right side, okay, if we plug into the Pythagorean theorem and it works, then we have a right triangle. However, if c squared is smaller than a squared plus b squared, then we have an acute triangle. If c squared is bigger than a squared plus b squared, then we have an obtuse triangle. So let me demonstrate that for you, please. Ben.
So when they're equal, it's a right triangle.
Yes.
And can I go fill up my water?
Okay. Now right now. So just to like kind of conserve some space, let's go up here. 8, 7, and radical 113. Which one would be the hypotenuse? We know a radical 113 is between 10 and 11. That's the biggest number. So it's going to be the hypotenuse if it's a right triangle. Okay, so when we do a squared plus b squared equals c squared, we have 8 squared plus 7 squared equals 1 squared of 113 squared. Okay, so help me out. What is 64 plus 49? Okay. And what is the square root of 113 squared?
113.
Oh,
Squared. Because the square root and the square are gonna cancel. Yeah? Yeah. What'd you say, Paxton? What? Yep. Okay, 5, 8, 10. So when we plug this into a squared plus b squared equals c squared, which one needs to be our c?
it's not right.
It's not.
That's
Yeah,
awesome.
no, it's
So what's 25 plus 64? It's 89? Okay.
Oh, wait, it's not
Wait,
right.
can we just like hold the reins a little bit? Let's all be together. 25 plus 64 is 89. 10 squared is 100. So c squared is bigger.
No. Wait,
Where does 5 squared go?
So it's up to you.
Oh, I didn't.
Okay. So since c squared is bigger and obtuse is the big angle, we have an obtuse triangle. Good? Okay. Now let's talk about a triangle with side length 14, 10, and 15. Which one needs to be the C? So 10 squared plus 14 squared equals 15 squared. So 296. So C squared is smaller. And when we think of triangles, our smaller angle isn't a cube. Look at that. Gonna. Okay, so you're really stuck on last chapter, or 2 chapters ago. If we add these two and it's bigger than 15, then we have a triangle. So that's good. If these two were smaller, we wouldn't have a triangle at all.
24 is 14 plus 10. And then 15. Since 24 is bigger than 15.
Then we have a triangle.
Then 24 squared. 24 is bigger. 5 plus 5 equals 10. That's not a right triangle.
So now, order of operations say that we have to take the exponents before we can do the addition. So we have to do the 10 squared and the 14 squared before we can do the addition. Okay? Okay. So very quietly, turn to the next page, and your homework is your student journal, page 246. Now, I will tell you that there are a couple of those problems where you're really going to need your calculator to help you out with simplifying the radical. Like, look at number 1.
Yeah.
It's a
Hey, what's
doozy.
happening now?
246 is on.
Whoa, can you like
It looks
bring
like
any
no.
more attention to
It
yourself?
looks like no.
Maybe that's the answer I should stick with then. Hold on, let me.
Wait, I asked before. No, I asked like